Okay, so this is the second part of the paper. So a printer buffer is a storage area that holds the data known as jobs that are to be printed by a printer. A simulation of the printer buffer uses a queue data structure to store jobs that are waiting to be printed. The queue is not circular. The printer buffer is represented as a 0 index 1D array with the identifier buffer as a queue. Okay, shows the current contents of the queue buffer and its pointers. Okay, right, well, state the purpose of the pointers queue head and queue tail. Points to the first element in the queue. Points to the last element in the queue. Well, there you go, that was hard for the tail and the head. Alright, let's move on to the next question. The function dequeue outputs and removes the next data in the queue. The function enqueue adds the job passed to the queue. Show the final contents of the queue and the pointer values after the following instructions have been run on the queue. Right, well, I'm going to delete this and then put this here. And then I'm going to, oh, it's a perfect size, look at that. One. Now, I'm assuming, that doesn't really state, so it's quite not well explained here, that we've got the data from the queue as before, because otherwise dequeue will do nothing. So I'm assuming we've got these things in here now, which is, so 1, 2, 3, 4, 1, 2, 4. Five, job 126, and job 127, and of course, current, I've got that. Current that will be 0, and the current tail will be 3. Okay, so dequeue. So it's a queue, so it's first in, first out. So these two will be dequeued, and the head will move to 2. Enqueue this, so that will end up going here, and tail will be 4. Dequeue, so this will delete, and head will be 3. And then enqueue job 219, 129, sorry, and so that will be there. So there you go, I think that should be it. Right, so now I've got to write the method function, dequeue. The array buffer and pointer values are declared within global scope. Function dequeue returns null if the array is empty and the contents of the next element if not empty. The queue is not circular. Okay, so let's just start with this dequeue. So if queue head is greater than queue tails, I mean, this is a terrible implementation because obviously once this fills up, you're screwed. Like, it's never going backwards. This is not good. But anyway, this is the implementation you've been asked to do. Then we're going to return null. If it's not, we're going to go, now we're dequeuing. So that means we're taking one away from the front. So this one's going to go away. So we need to move head up and then return head -1. So plus equals 1. Return is equal buffer. Buffer -1. Yeah, that should be it. That's it. That's dequeue. Define dequeue. Yeah, there you go. That's that. Right. Okay, is there one up there? The function enqueue returns -1 if there is no space in the queue to add data, and returns 1 if the parameter says the buffer. The array buffer contains a maximum of 100 elements. Okay, so if queue head is greater than or equal to 100, then return -1. So let's put that to enqueue, and we'll take value. So basically, if we've got no space, if the head is at position 100 or more, because the array will finish on 99, Increase queue head by 1. Yep. No, hold on a minute. I'm being dumb. Let's go back. Don't make the mistake I'm doing. We'll go in here. We want the tail is greater than or equal to 100. And then if not, we're going to do queue tail plus equals 1, and then buffer. Actually, I'll just do it the other way around. I'll do buffer tail equals value. I want to cut that and that. Oh. Yep, check if the tail's at the end. If it's not, if it is, return -1. Otherwise, set the value. No, actually, I just realised we want a tail is the last thing in the list, so we do need to do that first. So you have to check. Yeah, you have to increase tail, because tail is the last element, not the next free space. So go on to the next free space, and then, now actually, hold on a minute. Now then, let's see why you got to think this through. Then that needs to be 99, because it's full on 99. Yeah, not 100. So that's why you got to check afterwards, do your logic, run it through in your head. So if the queue is full, then this tail will point to 99. That means we've filled the whole thing up. Right, okay, there we go. Nearly made a mistake. So you've got to be very careful with these things, not to make a mistake. And it's why you've got to check it a lot. So, oh my God, nearly made another mistake. Return 1. Okay, probably should return true or false. Anyway, there we go. Anyway, on to the next one. Right. In the main program of the simulation, the user is asked whether they want to add an item to the queue or remove an item. If they choose to add an item, that's to input the job name and the function in queue is called. If they choose to remove an item, the function dequeue is called, and then the job is output. Appropriate messages are output if either action cannot be run because the queue is empty or full. This is a really, really easy program. So let's get the option. In queue. I'll just do 1. Enter 1 for in queue, or 2 for dequeue. And then get rid of that. So if option equals 1, we're in queuing. So then we need to ask them what to in queue. Value equals input. What job shall we add? And then we just value. In queue value. There we go. Else, we picked option 2, so we do item job equals dequue. Now I'm going to do I know I haven't done the error messages that are going wrong, but that's okay. I'm going to do that after, which obviously if you're writing you'll be more careful of, but also I'm typing, so it's not too bad. So if they cannot do the things, a message will go. So for in queue, it will return 1 or -1. So let's show for in queue. Right, okay. So in queue, so t equals in queue. If t is equal to -1, print queue full. Else print added. No, it doesn't say that. I just got to write that really. And then here, job dequeue. What does job dequeue return? Does it return -1? No. Okay, so now it returns null. If job is equal to null, print empty queue. Else print job. I think that's it. We've got to check though, because you can make mistakes easily. If that is now not put them and the functioning queue is called, yeah, that should be it. Let's go on to the next one. Probably I would put a message there, but I don't think it matters. Right, let's have a look. Oh, got some more space there. The queue is changed to make it a circular queue. Describe how the function queue would need to be changed to allow buffer to work as a circular queue. Right, so, right, in a circular queue, the pointers will rotate. Is that a better way of putting it? Will move round to the front if they ever go over the size of the array. So if the size of the array was 10, 0 to 9 positions, if the pointers ever got to 10, they would be put back to 0. This is done using a mod function, which gives the remainder. Here, we would do head equals q, head plus 1, mod 100 to get its real position. Its circular position, I'll say, in fact. Yeah, I think that's probably it. Now, I've just checked the mark scheme, and they've, I think, unfortunately, not really bothered to sort of worry about mod that much. But anyway, they're also saying when checking for full, you would need to check also for you head to be equal to 99. Is it the head at 99 or tail at 99? Oh, what would be front? And tail is 0. But I would just be doing the mod function when I check them. So I don't really agree that's true. But anyway, it's on the mark scheme, so I'm going to put it on there. But I would just be doing if here where we do if q equals tails. Actually, would it work? I suppose this is a difficult one, isn't it? Because you've got to check that no longer works if it's circular. So you would have to do a different check. But yeah. Anyway, let's move on. Some print jobs have different priorities. The higher priority, the sooner the job needs to be printed. Describe how the program can be changed to deal with different priorities. So they could use either 3 different queues for priorities and allow jobs to be added to an appropriate queue. They can also use a multi-level feedback queue, which will have priority built in, and higher priority jobs will go to the front. Or done in high, medium, low order. Something like that. Well, I don't know if that's a perfect answer. Right, let's go on to the next one. Okay. Describe the pointer. It's quite an easy one. It's very similar to the last one. Describe the purpose of the free list pointer. Oh. It holds a pointer to the address of the next free spot. That's not really That's weird, isn't it? Anyway, there you go. Each node in the linked state value points to the next item. Null points on the first current list and the head 3 pointer. State purpose of the head pointer is it holds a pointer to the address of the first element in the list. The list. Okay, I suppose, okay. Is where the next new item could be created. Right, here I had to put the table in. So this shows the contents of the linked list from figure 3 and the pointer values when the node with data 6.9 is deleted. Right. So let's delete 6.9. Bye. Now, I missed this, but you have to be careful here because obviously 4 points to 5, which points to 6. So we put 3 in here, but it is important that this free spot points to 4. And I very nearly missed this because otherwise you might know that's the next one that the free one links to. Now, I know it looks like you don't need it now because everything's sequential. But if we were to delete one out of here, this would actually need to point to 3 or whatever. So that needs to point to 4. That's my other mark. And then at the moment, that's pointing to 3. Obviously, 3 is dead. So 3 was pointing to 2. So if we go back, sorry. So I changed what is pointing to 3. That now points to 2. So I've skipped it. I need to change that to 4, which is the next free item in the list after the one I'm on. So when we add one here, we know that that goes there. And is that it? So 2 points to 2. That points to 1. And then that is that. So they're my 4 things I've done. I've changed that, and that. And yeah, that should be it. That was a tricky question, and I could easily have missed this. I'm not even sure it matters, but anyway, I did it. So let's go on to the next one. Oh, my easy peasy, easy money. Right, so let's get the class up. I'll just put it here, and I'll move it down after. Right, an algorithm using pseudocode or program code to create the class node, its attribute and constructor. Do not write the get and set. So, okay, class node private float data. Oh my god, that is some tab distance. Why does it do that? And I press space. I don't know why it's doing that. That's this tab. Private float data, private integer pointer. Then new. It's just that. Is that all it is? New. Okay, so public node, and that takes a new data and a pointer. So float new data in new pointer, and then all we got to do is go that equals new data equals new pointer, and that's it. Think no, yeah, I mean that is easy peasy. Too easy, so unfortunate if you're doing this exam because you want a little hard one there to get some more marks. But there you go, 4 marks. Right, next. Describe the difference between get and set methods. Okay, that's not difficult. So get methods will return a value from one of the attributes in the class. Set methods will change or set one of the values of the attributes in a class. So it will need a parameter, 3 parameters. There you go. Easy peasy. The function find node path takes the data items from the linked list as a parameter. Takes data item to find the linked list and follows a pointer to find it. Described by the function will search the data and return the required message. Return arrays all they visited and joins this to a certain message statement data was found or not found. It returns this one long string. Okay, so it's going to. It's interesting bit of coding. Try and get it the same size. Look at that, perfect. Right. So find node path. Can I just write the code? We'll start at the head node and check if it is the search item. If it is, we will print out the. We will return the string found plus the data we are looking for. Actually, what I'll do is I'll start a temporary string. No, actually, I got temporary string called path to blank. And then I'll add path here. Add head node value to path string. I need casting. If it is what we are looking for, then we will return the string found plus path. Otherwise, move on to the next item in the list by following the pointer. Keep repeating this until it is found, and we return the found plus path string. Or we reach a pointer to -1 and return not found plus path string. Now let's go double check that oh, it's the array indexes. I just realised it's the array indexes. So not the head node index to the path string. If it's what we search for, then we'll return the string found. Otherwise, move on to the next item on the list by following it. Keep reading this until it is found. Otherwise, move on to the next item by following the pointer and add index to string. Casting required. Keep repeating this until it is found, or return, and we return the found string, or each pointer to -1 and return not found plus path. That's pretty much robust, I think. Right, let's look for the errors in this code, apparently, because that's what we've got to do. So, it's a procedure called print linked list. Well, straight off the bat, why would you be setting it to temp pointer, head pointer -1, and then checking if it's -1, and print the list is full? That head pointer would be -1 if the list is empty, not full. So this is dramatic error. So line 2 should be temp pointer equals head pointer. That's the straight away you're doing all these things, because you're going to move temp pointer to head pointer's pointer, so on and so forth. And then here another error straight away is 05, and it should be print list is full, empty, not full. Because if it's -1, then the head pointer points to nothing, so there's nothing in the list. Now let's look. There's always going to be right. So there's a syntax error here, because you can see there's no pointer. This is run the wrong way, so take your pick. I'm going to do this one for giggles. And so that's line 11. And then it should be that, I think. Just a little bracket, but hey, it makes a difference, because otherwise it ain't going to run. Everything plus linked list temp pointer, I'll get that. Yeah, there we go, that's it. Right, let's go on. Oh, I've got so much more to do and I'm getting really bored now. Right, so let's go. Okay. Describe 3 features commonly found in ID Bunny to debug his program. Debug. Okay, debug. The best ones are breakpoints. These allow the program to pause at a certain point and then you can step through the code and see what happens. Okay, that's one way for debugging. Watchers. These allow you to see the current value of a variable and you can even change it to test the program. The main 2. And then I'm going to go third one, profiler. This allows you to see CPU or memory usage and find out what might be causing a problem with the code. There you go. There's quite a few for that, but they're my favourite ones, if I'm being honest. Yeah, that's basically it. Right, so Barney would like his linked list to be part of a base program that is saved in a library. This means it could be reused and changed by other programs. Discuss the benefits of using different object-oriented techniques that Barney could use to achieve this. Right, so obviously object-oriented techniques, straight away you're thinking Barney could make use of a class for his linked list. Classes are templates for data structures that can have both attributes and methods. By creating this way, you can create more linked lists when required using the new keyword. I don't know how I'm writing that, but I am. This also adds a level of encapsulation, data stored inside itself, to improve security. Inside an object, which he might need on other projects. It's pretty good. Basically, just chat about object oriented. So he could also make use of inheritance, allowing him to create subclasses of linked lists with more specific features. Inheritance allows a class to inherit to gain access to the attributes and methods of the parent class. This could be a useful feature in a more complex system. Okay. Yeah, you can even overload by alternative methods run by inherited class. Methods from the parent class and make use of polymorphism, which is where the computer will select the method from the class or subclass depending on the type. I don't know if I'm explaining that well. Overall, if he wants to create a library, a class is a great encapsulated structure that will allow him It's encapsulated decomposed structure as well. Decomposed structure that will allow him to maintain his code, because it is easily improved and debugged. I think that's about as much as I'm going to write on that. I think that's pretty much paper 2 done. I can't think what else I could write. I'm sure there's more I could write, but that's pretty good. But yeah, there you go.